All right, we're going to look at volume on this video. And so I'll kind of just start this one the same as perimeter and area and give you an idea of where to look for volume help on your test if you see a volume problem. And so again, you'll get your reference materials or your mathematics chart out and you'll look towards the bottom, and I'll circle the bottom portion here where it's talking about volume. And so you're going to be looking at a couple of different formulas. One, if you look at the volume for a cube, it is S times S times S, or side times side times side. We'll look at that here in a second if we're trying to find the volume of a cube. If it's of a rectangular prism, you actually could have two. It's length times width times height, or it's the area of the base times the height. And that's a little bit different. We'll look at that on an example here in a second. But basically, it kind of ties in with length times width times height. So we'll kind of look at that. But here are your, again, this is your help if you need it on the day of the test. You need to look, at this chart if you're struggling, and that might kind of refresh your memory on volume if need be. All right, so on this page, we're looking at our notes that we take for volume. Here you'll see an example of a cube and a rectangular prism. I think, again, kind of going back to perimeter, area, and now with volume, it's still very important to understand what volume is and to get a good feel of kind of where they might I guess where they might go as far as a question might, look like on a test. And so the way I always kind of describe it, and again, it's going to be kind of hard now through a video, but I always just kind of think about a volume question being you're filling up a three-dimensional object with what are called cubic units. So probably the easiest one to think about are the little unit cubes that you've probably used in your math classes before, and just kind of have that in your mind and just kind of think about, okay, if I had those unit cubes, and if I were filling up a box, how many of those unit cubes would it take to fill up that box? So in your mind, when you think about volume, you're filling up a space, and you're filling it up with what are known as cubic units. Now, those cubic units that you're maybe thinking about in your mind, those are centimeter cubes. So those are cubic centimeters. Those are really small cubes. But you got to keep in mind also that there are different units out there. So there are cubic inches, there are cubic feet, there's cubic meters. It could go all the way up to something quite large. So when you're thinking about volume, I think probably the best thing to keep in the back of your mind is you're thinking about how many cubic units does it take to fill up a three-dimensional shape. So in this case, when we have it on paper, like what you're looking at here, and you're looking at, we'll start with the cube, even though that's not really what we're going to be doing to solve this problem, we're going to rely more on a formula. But in the back of our mind, we can still think about how many cubes it would take to fill up, this larger cube. So how many smaller cubes would it take to fill up this large one? So the volume, the formula for the cube here is S times S times S. So I'm just going to write in a couple of other dimensions here just to kind of give us a pretty good feel for what this might look like. So I'm going to fill in just a couple more. And again, in your mind, you're thinking about really solving this with a multiplication problem, or maybe problems in this case, where the math's going to be pretty easy. We're just going to have to kind of go slow and think our way through it. But when we're solving these problems, really and truly, it just kind of falls back on, math facts a lot of times. Usually, I'm not going to say all the time, but usually they'll give you whole numbers for volume problems. They might throw a decimal at you. I seriously doubt they would throw fractions at you. I guess they could, But most of the time it just falls back onto something like this problem. So I'm just going to write what we have here. We've got 6 times 6 times 6. Some kids, though, I will say this, some kids really want to rush through this and they really want to just kind of maybe do mental math, and they might see this problem as 6 times 3 and they might be looking for 18 as an answer. Well, that is not going to be the case at all, because we're going to have a much larger answer than 18. If I do the math here, 6 times 6, my first problem is 36. And then I have to times 36 times 6 again in order to find the volume of this cube. And so I'm going to take my time here and I'm going to set it up like a traditional problem, and I'm going to multiply like a 2 by 1 here. That way I can get this thing solved and I can find out what the true volume is. So 6 times 6 is 36. I'm going to go now across. 6 times 3 is 18. I've carried a 3. So 18 plus 3 is going to give me 21. So I'm going to have an answer here of 216. The thing about this is, though, and whoever, I don't know who originally made these notes, but they kind of wrote in there IN. And so they're saying the unit here are inches. And so I'm going to write inches, but these are cubic inches. And so this is a little bit different from our square inches that we were talking about, or our square units that we were talking about for area. These are cubic inches. So instead of putting a little 2 as an exponent, I'm going to put a little 3. Those are cubic inches. That's the symbol that you would use for cubic inches. And so realistically, what we're thinking of here is we're looking at 216 smaller cubic inches is how many small cubes it would take to fill up this box here. And again, it's all about understanding that that's what volume is. It's not just doing the multiplication problem, finding the answer, and then you're good. It's understanding, okay, well, that's really what's happening. Okay, so for the rectangular prism, if we move down, I see some dimensions here. I see 9 centimeters. I see 3 centimeters. I see 2 centimeters. So I'm going to kind of break this down as far as what each one represents. The 9 on this one is kind of the longer side. So I'm going to say that that's going to be my length. So I'm going to start with 9 here. My width is probably going to be this part here where you're looking at, and you kind of have to use your imagination on these because they're three-dimensional shapes, but they're on paper or they're on a screen. So you have to use some imagination to kind of visualize what it might look like. But basically, it's from the front of this box, I'm going to call it a box, to the back of the box. And that's saying it's 2. And whoever did this put centimeters, so that's 2 centimeters. And then the height is how tall it is. And so from the bottom of the box to the top of the box is going to be 3. So I'm really going to have 9 times 2 times 3 when I go and I solve this problem. Now, you could solve it with the area of the base times the height. I think I'm going to wait on that until the next screen and kind of go over that one with you. So I'm going to stick to L times W times H. So I'm going to start here with 9 times 2. 9 times 2 is going to give me 18. And then my last problem would be 18 times 3. And what I'm going to do here is I'm just going to take my time and solve it. I don't want to try to do mental math here and make a mistake. 8 times 3 is going to be 24. 3 times 1 is 3 plus 2 is going to be 5. So I'm going to have 54. I'm going to write it over here. 54. And it's centimeters. So I'm going to write centimeters in here. But it's cubic centimeters. So these actually would be those little bitty tiny unit cubes if we were actually using these to build or to fill in this box. So in other words, how many of those little tiny cubes would it take to fill in? So if I have this as an answer here, and I really now kind of take a step back and looking at both of them, they weren't hard problems. They were just things that I kind of had to go slow on and figure them out. Again, though, keep in the back of your mind what you're trying to accomplish here, other than just seeing these formulas and multiplying. You're really thinking about, cubic units, what that means, and, how many it takes to fill up a three-dimensional shape. All right, on this last page, this is kind of a classic example of what a volume question could look like. They don't always look like this, but I know we do this in my class a lot of times where we build and we try to make three-dimensional shapes with these unit cubes. So when I've been saying unit cubes, this is kind of what I mean, these little bitty cubes that you've used in the past in your math class. Well, it kind of gives you a question here. It kind of says, what is the volume of this object? Well, again, if I know what volume means, it's how many of those cubic units does it take to either build an object or to fill up a box. Well, since this one's built already, then I'm going to just kind of use some imagination here, and I'm still going to stick to what I know, what volume means, and I'm going to try to solve this one. So I'm going to go back to kind of my basics here. So I'm going to show two. There is definitely length times width times height on this problem. Or there's also, hey, I could go find the area of the base. That's what that B represents. And then I can times it by the height. So I'm going to do both just to show the connection. First of all, I'm going to start with the top one. So length times width times height. So I'm going to switch over to kind of like a red color here to do this one. So I'm going to go and I'm going to basically label everything that I see here. And I'm going to start with my length. Well, my length is usually the longer side. So I'm going to count that there are 4 units here. And I'm going to say that these are going to be, it says cubic units, but I'm going to call them centimeters. Just because I think those are going to be centimeters. So I know my length is going to be 4. My width is going to be basically how wide this is. So I'm going to kind of draw a line here on the front part of this box. And I'm going to say, okay, that's going to be 2 centimeters. And then my height is going to be how tall it is. And so it's also going to be 2 centimeters. So really my problem is 4 times 2 times 2, which is pretty easy. My numbers are pretty low here. I don't have decimals involved, so probably could do this one mentally. 4 times 2 is going to give me 8, and then 8 times 2 is going to give me 16. So I'm going to label it 16 centimeters, but I'm going to label it as centimeters cubed, or cubic centimeters is another way you could say that. So basically, it's going to take 16 of those cubes to build this shape, this rectangular prism. And really and truly, if you were to go and look at this shape and kind of break it down and analyze it a little bit, I think you would probably agree that, yes, there are 16 there. I mean, you can kind of look at it in groups of 4. There's a group of 4 here, and then even though you can't really see all the cubes, I know that there's a group of 4 here also, and then here, and then here. So really, I'm looking at 4 groups of 4, or 4 times 4. So that's one way. That's kind of the traditional way. I'm going to erase this just to show the other way, because I will say that this is a pretty popular way to ask a volume question in 5th grade. Quite a few questions I've seen in the past deal with this particular formula, which is finding the area of the base and then timesing it by the height. And so let's kind of start with what that means. First of all, when you think of the word base, I would just simply say you would want to think about the bottom of it. Okay, base means the bottom. So if you were thinking about a basement, that's the bottom, part of a home. We don't have a lot of those here in Texas, but there's some older homes that probably have basements. If you were thinking about like the base of your shoes that you're wearing, you're thinking about the bottom. So probably wouldn't say it, but like if the base of your shoe was getting worn out, well then like the bottom of your shoe would be getting worn out from running around and whatnot. But again, though, just kind of breaking it down, when you think about base, usually you're picturing the bottom of something. Well, in this case, base is the area of the base. And so the area of the base is taking this bottom layer here, and I'm going to try my best to show that. It's that bottom layer, and it's finding the area of it. Well, if we go back, area is just length times width. So the area of the bottom in this one is just 4 times 2. And so 4 times 2 gives me 8. So I know that there's 8 of those cubes sitting on the bottom. Now, if I times that by the height, well, the height of this was 2. And so you're going to see some of the same numbers that we were dealing with length times width times height. You're just going to see it in a different format, or you're going to see it in a word problem where they're talking about the base. And so in this particular one, if the height is 2, 8 times 2 is going to give me 16, and I'll get the same answer. The thing that I always kind of revert back to is really look at the first formula. The first formula is length times width times height. Well, if I take the first two, length times width is just area. And so really, even though they look different, they're the same formulas. It's just going to be how they give it to you in a problem. Sometimes they'll just straight ask you for the volume. And if it's just a straight volume question, then go with your formulas, length times width times height, or S times S times S if it were a cube. But if it's talking about the base, then maybe you switch gears a little bit and you think about that bottom layer. Layers are kind of a key word, especially if it's this type of picture that you're seeing on this problem. I've seen some problems where they talk about how many layers it would take if you had a base that was 16 and they wanted to know how many more layers would it take to get up to 64 or something like that. And so it's, again, you're still thinking volume, but it's just they're giving it to you in a different way. So if you see that formula, the second one, V equals B times H, don't freak out. It's just a different way to show volume. All right, so these are just kind of some basic volume formulas, some basic volume problems that you guys will be seeing. I think, again, to be honest, it's fifth grade, and just to kind of let you know what's coming, you're going to see some of these problems. They're going to be a little bit more complex than these. Again, probably in some type of a word problem. But just go slow and really read it carefully and think about what are they talking about. If they're building up layers, if they're filling something in, how many cubic units does it take to make a shape, then you're going to be dealing with a volume question.